Fellow mathematicians, we have been dealt an extremely difficult math problem. But luckily for you, I will be here to guide you through this problem, take it along with you, teach you the methods how to do it, and hopefully you'll be able to solve this problem, understand it, and also do further problems like this in the future. So the most important thing before starting a question is let's just read the question. Slips of paper numbered 5, 10, 50, and 100 are placed in a hat. How many different sums can you get if you draw two numbers with A, replacement, and B, no replacement? So, if you're just starting out this problem and you don't know much about probability, let's say you don't know that much, a little bit of a noob, you just started, you don't know that much. What is replacement? What is no replacement? So let me explain that to you. Replacement. So just by the language of it, replace. So that means that after you draw a number from the hat, so let's say an example that we have here, 5, 10, 15, 100. Those numbers are in a hat, slips of paper. You draw 5. The next number that you would draw, you would put that slip 5 back in the hat. So instead of after you draw 5, the only options left being 10, 15, 100, the four options are actually going to be the same as your first drawing. So that's what it means to have replacement. B, no replacement, is basically the opposite of that. So after you would pick 5 out of the hat as your first drawing, you wouldn't put it back in. So the only options would be 10, 50, and 100 for your second drawing. So let's just say, for example, you draw another example. You draw the number 10 on your first drawing, and we're doing this is with replacements. We're doing part A right now as another example. You draw the number 10 out of the hat. You would then put that number back in, and then you draw again, and you have 10 again. So your sum could actually be 20. As in no replacement, your sum could never be 20 because once you took 10 out, there's no another 10 to choose from. That's already out of the hat, and that's already over. So that's the first part. Now, hopefully you understand the difference between replacement and no replacement, and then we could further delve into the problem. We've already explained what is replacement and what is not replacement. I think it's important that we start delving in to the actual question itself. So the question is, you're taking slips of paper 5, 10, 15, 100. So we're going to start with replacement. As we've already explained, that means you put it back in. So I actually have a hat, slips of paper right here, evenly spaced as best as I could possibly do. So I'm just going to kind of do an example drawing for you a couple times just to see kind of the feel that you can kind of get the different possibilities you have for replacement. So put my hand in the hat, take one out. The first one is 100. Because we're doing replacement, I'm going to put this 100 right back into the hat. Right back in. Right back in. Replacement. Right back in. Mix it up, mix it up, mix it up. Gotta be fair. Never know. Casinos are sketchy. Gotta be careful. I got 5. So that means my sum would be 100 plus 5, 105. So that is an example of a sum that you could possibly get with replacement. And you can see that right here, that's option 14, 105. So those are one of the options. But as you'll see, that there are a lot of crossovers that can potentially happen with replacement and also without replacement. But let me give an example. This is not luck. I'm going to pull purposefully. I'm first going to pull a 5. So I pull the 5, and because it's replacement, I put it right back in. Right back in. And then, okay, whatever. I then pull a 10. Okay, so now my sum is 15, right? So that is one possible sum. 15 is a possible sum that we could see, and that can be seen in option 2. 5 plus 10 equals 15. But now, what happens when I go and I get 10 first? I get 10 first, and then I go 5. Or I first get 5, then I go 10. You see, those are two different possibilities, but they result in the same sum. So that means they're not unique possibilities, and that one of them would have to be crossed off. So far, those are some examples, and then also you can see in the slide of examples of with replacement. And then I'm going to show you all the examples with replacement that then get crossed out because of over. Counted all the possible options that we have with replacement. There's going to be a lot of overlap, like I mentioned in the previous video. There's going to be tons of overlap with different sums, and we're only trying to get the unique possible sums that can be derived from the different slips of paper in the hat. So then we have to go count what slips are unique. So 5 plus 5 equals 10. That's unique. 5 plus 10 equals 15. That's unique. 5 plus 50 equals 55. That's unique. 5 plus 100 equals 105. That's unique. 10 plus 10 equals 20. That's unique. So far right there we have, that's already 5 options. But then we get our first overlap at 10 plus 5 equals 15. We already have that at 5 plus 10 equals 15. So 15 is a sum that we've already seen. So we want to see new sums. And then we'll see number 6 at 10 plus 50 equals 60. We'll get a 7 with 10 plus 100 equals 110. We'll then get 8 with 50 plus 50 equals 100. And then we have more overlap again. We have 50 plus 5 equals 55. We've already seen 55. In option 3, we've already seen 50 plus 10 equals 60. We've already seen that in option 7. So then the only two more unique ones are 50 plus 100 equals 150. And then we also have 100 plus 100 equals 200. So that totals out to 10 total possibilities. So the answer with replacement of how many possible sums you can get, the answer to part A would be there's 10. There are 10 possibilities. Now we already figured out the answer to how many possible sums there are with replacement. We're now going to be moving on to without replacement. So like I kind of previously said in the very first video, without replacement means that once we pick a slip, it doesn't go back in. Sorry, it's not going to go back in. It's staying out forever. Never goes back in. So that is without replacement. So now that we're doing without replacement, I'm going to kind of do another little example with a handy dandy hat and see how that works. Just to kind of show you guys physically how that works without replacement. So let's say I pick the first one. The first one I got is 10. So I got 10. So now 10 wouldn't go back in. So I could actually never get the sum 20 like I was able to get in the first example with replacement. So now I take out 10, take that out, and then I take 5. So there's still similar sums, like that's 15. That's a similar sum that we've seen, but the sums like 100 plus 100, which equals 200, that's a sum we'll never get. 50 plus 50 equals 100, that's a sum we'll never get. 5 plus 5 equals 10, a sum that we'll never get without replacement. So now let's look at the certain possibilities that we can get without replacement. So we still have 5 plus 10 equals 15. Then we have 5 plus 50 equals 55. 5 plus 100 equals 105. So a lot of similar ones, but there's some missing. And then, of course, like with the first example that we did with replacement, there's going to be some overlap. So after we do this, we're then going to calculate the overlapping ones, and then we're going to finally calculate what possible sums you could have without replacement, the actual final number itself. We're going to end this problem well. We're going to end this problem with precision. Part of this problem is we need to calculate the overlap of different sums for the without replacement questions. So to calculate this, we're just going to simply calculate which sums have we already seen. So 10 plus 5, option 6 equals 15. We've already seen this. 5 plus 10 equals 15. We already seen that. We already saw that in option 1. 10 plus 50, not 10 plus 50. 50 plus 5 equals 55. We've already seen that. 50 plus 10, we've already seen that. 100 plus 5, we've already seen that. 100 plus 10, we've already seen that. 100 plus 50, we've already seen that. So the only options that are original, we have 5 plus 10, 5 plus 50, 5 plus 100, 10 plus 50, 10 plus 100, 50 plus 100. That totals out to 6 unique possibilities without replacement. So to end this problem off with replacement for this problem, the answer is going to be you have 10 different possible sums. For without replacement, you're only going to have 6 possible sums. And so the reason why without replacement obviously it has less sums is because that every single time you're picking, you're going to have not another possibility because you took in another slip out. So you'll never have 10 plus 10. You'll never have 100 plus 100. You'll never have 50 plus 50. And you'll never have 5 plus 5. So that is why there are 4 less options in without replacement. So that concludes the problem. Hopefully you learn how to do it. Hopefully you learn how to do other problems of this sort by kind of crossing them out, figuring out the different options, and solving it in that manner.